Empirical and molecular formula. As we discussed in the last class, we have introduced this concept. Empirical formula of a compound is the presentation of elements in a compound in the simplest whole number ratio. Here this term is very important, whole number ratio and the simplest whole number ratio. That is called this representation is called the empirical formula. For example, the molecular formula of butane is C4H10. So the elements present in the compound are carbon and hydrogen. The simplest whole number ratio of carbon and hydrogen is 4:10, means 2:5. We will not make it as 2:2.5. It will be 1:2.5. We will make it as 2:5. That is the simplest whole number ratio. Therefore, the empirical formula of butane will be C2H5. The next one is for any ionic compound. That is the compound where the ions are present. These are not the true molecule like C4H10, butane, all these are covalent molecule. Later on you will see the bonding. This ionic molecule, these are the groups or cluster or aggregate of oppositely charged ions. So, what we can say in sodium chloride 1, I may show you this model also after some time. So, this is a sodium chloride in which we have alternately placed Na plus and Cl minus. This is how this all are Cl minus of equal size, and at the middle this all dots stands for Na plus. So in this we have, in a particular crystal we will have, again if we will just join this we will again get another more cube and so on. So in this what we actually find, whatever is the number of Na plus, let it be x, we have equal number of Cl minus. So in a crystal it is actually Na plus x, Cl minus x, and the simplest whole number ratio here we are calculating as Na plus Cl minus, or finally the representation is NaCl. So these are the examples of empirical formula. Let's start with molecular formula. This molecular formula gives the actual number or exact number of elements present in a compound. So, though the empirical formula of butane is C2H5, the molecular formula is C4H10. That means it is exactly containing one molecule of butane exactly contains 4 atoms of carbon and 10 atoms of hydrogen, or a compound butane is made up of 4 elements carbon and 10 elements hydrogen. So then if we will say that the molecular formula of water is well known, H2O, then it means in a particular molecule of water we have 2 hydrogen atoms and one oxygen atom that is present in one molecule of water. This is the exact number. However, this molecular formula at times be equal to empirical formulas. This is the present case only where the molecular formula is same as the empirical formula, because hydrogen is 2, oxygen is 2:1. So its molecular formula is also H2O and empirical formula is also H2. Now in this context, okay, molecular formula of a compound is either equal to its empirical formula or is integral multiple of its empirical formula unit. And this integer we will get through certain rules that we will get. So what actually I am writing, this molecular formula is equal to empirical formula whole n. This n is an integer definitely. To be more specific, this n is not equal to 0, neither this n is any fraction or any negative 1. So integers could be negative also, could be 0 also. In fact, this n is definitely a natural number. This n is equal to molecular mass divided by empirical formula mass. I am showing one example. So if the question is, suppose, just an illustration, after that I will solve the question. The molecular formula of glucose is C6H12O6. That means the molecule of glucose, a single molecule of glucose contains 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen. So its molecular mass, we know how to calculate the molecular mass, is equal to 6 into 12 plus 1 into 12 plus 6 into 16. That is equal to 72 plus 12 plus 96, or that is equal to 180 U. Empirical formula is C is to H is to O is 6 is to 12 is to 6, or that is the simplest ratio is 1 is to 2 is to 1. So the empirical formula is CH2O. And now if we will calculate the empirical formula mass, it comes equal to CH2O means 12 plus 2 into 1 plus 16. That is 12 plus 2 plus 16, or that is equal to 30U. So this N is equal to molecular mass, which is equal to 180 divided by empirical formula mass 30, or that is equal to 6. As N comes equal to 6, now we could explain this as the molecular formula is equal to empirical formula whole n, and here n has come equal to 6. So this is equal to CH2O, what we got, whole 6, or that is equal to C6H12O6. That is how we are calculating the molecular formula with the help of empirical formula. Also, I'll tell one more relationship. What you will find that the molecular mass is equal to 2 into vapor density. Just keep it as a relationship. Later on, through Victor Mayer's technique, it will be established in class 12 what is the vapor, class 11 sorry, what is the vapor density and how actually this molecular mass is equal to 2 into vapor density. Right now you just keep this formula in your mind. And now if it is asked, suppose the one question, a compound the empirical formula CH3, its vapor density is 15. Find, vapor density has no unit. Find the molecular formula of the compound. Now the solution comes as what is given. Empirical formula of a compound is CH3. So empirical formula mass would be for CH3 it is 12 plus 1 into 3, that is 15 U. What is given? The vapor density of the compound is 15. So what we got, the molecular mass is equal to 2 into vapor density, or that is equal to 2 into 15, that is equal to 30 U. Now N, this N factor is equal to molecular mass by empirical formula mass. So this is equal to molecular mass we got 30 divided by empirical formula mass we got 15. So that is equal to 2. Therefore, the molecular formula of the compound CH3, the empirical formula, whole N2, or that is equal to C2H6. This is how we are actually solving such questions. Now accordingly, I'll provide 2-3 more questions related to this. So after watching this video tutorial, you are supposed to solve these questions, send me the answers, then I'll send you the next video.